So the lower fence came out to be 4.5. So I get to say any observation less than 4.5. What's 4.5? Isn't that $4.5 thousand, right? So $4,500 is an outlier. Did any school charge less than $4,500? Let me see. Go back to the list and see. Any number that is smaller than 4.5? No. Look, guys, the smallest number is 16. So there is no outlier to the smaller side. No school is charging way too little to be considered an outlier. But I have a strong feeling we're going to have an outlier that is just way too expensive. So let's go back to the slide and let's find the upper fence. Okay? So that's how you find the lower fence. Now let me go and find the upper fence with you. Okay. This is how you find the upper fence. Okay? Upper fence formula is Q3 plus 1.5 times IQR. Okay? What is the Q3 here? Q3 is 47, and I need to do plus 1.5 times IQR of 17. So let me go ahead and just copy this to my scientific calculator. And the outer fence is 72.5. So let me type this over here. 72.5. So any observation greater than 72.5, or in dollars, that is $72,500 is an outlier. Did any school charge more than $72.5 thousand? Let me go back and see. The school number data. No, none of them did. Hey, that's very nice. So there's no outlier. There's no outlier. Oh, I wanted to get an example that has an outlier. All right. Hold on. So let's see. Unfortunately, we didn't find any outlier because nothing was smaller than the lower fence and nothing was greater than the upper fence. That's kind of boring. I want another example. But until I can come up with you know what? Hey, the superhero data that I assigned as practice problem for your exam test 1, that one's going to have some outliers. So how about we do that in our other video? In another video, we'll go over that. But I was upset because this example doesn't have any outlier. Maybe that's a good news because this is about tuition, right? College tuition. No college should pay, should charge way too much. So, okay. I'm all right with that. All right, so we found the solution. There is no outlier because nothing was smaller than the lower fence. Nothing was bigger than the upper fence. Let's go on then. What's next? I'm going to delete this slide. How about box and whisker plot? And this IQR method, guys, there is a way for us to see. I'm going to show you something, okay? Go to StatCrunch and go to graph and click on box and whisker or box plot. It's called box plot. Click on box plot and then create a box plot of the tuition cost. But if you come down here, you should be able to tell this StatCrunch. Hold on a second, let me find it. Oh, here it is. Look, use fences to identify outliers. It's a default, it's checked already. So we can ask the StatCrunch to create these upper and lower fences. They're not going to tell us what they are. So that's why I'm going to ask you to find it yourself on your test. But it's going to mark any outliers with the star. Okay? In our calculation, there were no outliers, so I better not see any stars. So take a look. I'm going to go ahead and click on compute. You see there's no star or any kind. It's just a box and whisker plot. But let me go ahead and create another data set, okay? How about I just copy this tuition cost, But this time, let me add some crazy numbers, okay? How about a school that charges $80,000? $80,000. That's too expensive, right? How about I add another one, like $95,000? That's very expensive too. So I am trying to show you that if I have an outlier, StatCrunch will automatically do this lower and upper fence and mark these outlier values with stars, okay? And while at it, let's create another one that is on the smaller side, something too cheap. How about a college that only charges $1,000? Okay? All right, let me create a tuition cost number 2. So I'll go to graph, box plot, and I'll click on tuition cost 2, and I'll tell them to use fences to identify outliers. And why not? Let me tell them to draw the boxes horizontally. Look at this for me. I'm gonna go ahead and click on compute. Ta-da! So here is what I got. Let me go ahead and make this a little big. I can see that 95 was flagged as the outlier, but they did not mark 1 as an outlier. I would think they would have. Why didn't they? So I kind of want to do this problem myself now, but it didn't mark 1 as an outlier or 80 as an outlier, but this is what you guys can use. Maybe I can look into this a little bit later after recording. I was expecting to see both the 80 and 1 as well as 95 marked with the little dot, but they didn't mark them as outliers. Maybe they are not outliers anymore. How about if I change this a little bit? But I think I should get back. How about if I put like 0 there? I don't think it will mark it, but let me try one more time, okay? Graph, box plot, tuition cost 2, draw boxes horizontally. It's still marked only this one as an outlier, but 1, 0 is not an outlier. Now I'm wondering, did I do my math right? I'm out here looking at my lower fence. So I need to do Q1 30 minus 1.5 times IQR. Did I type this in wrong? I mean, I'm actually doing a different problem, so okay, 4.5. I don't know what happened, but I was creating another one. Maybe I can do another. Guys, skip forward. I'm just investigating what in the world is happening. You can skip forward and just watch the other parts. Maybe I need to stop recording, but you may be wondering too. So tuition cost 2. What if I do Q1, Q3, and IQR? Okay. And if I do the calculation a little bit over here, Q3 minus... you know what's bothering me is that I want to know why that tuition of 0 is not flagged as an outlier. But if I do Q3, Q1 of 27 minus 1.5 times IQR of 22. Oh, I see why. Look. This second data set has a lower fence of negative $6,000. No colleges are paying anybody to, you see what I mean? It's a negative number. So there is no number that is less than negative 6. That's why they did not mark 0 as an outlier. What about the upper fence? Upper fence of this new data set that I just randomly created is 49 plus 1.5 times IQR of 22. So anything greater than 82 is an outlier. So by adding 2 additional numbers on my second data set that I randomly created, I changed the IQR so much. IQR went from 17 to 22. It didn't even flag 0 as a potential outlier. Okay, well that was pretty cool. But let me get back. I hope you understand how to find IQR, lower fence, and upper fence from watching the last 20 minutes of this video. Okay? Alright, but now let's go on. Let's talk about box and whisker plot, which we kind of already did. Alright, let me go ahead and present this. So box and whisker plot, or aka box plot, it highlights important features of the data set, and the important features are these 5 numbers, and we call them 5 numbers summary. Look at the words, okay? The first one is minimum, first quartile, median, third quartile, and maximum. So if I ask you to find 5-number summary of a data set, these are the 5 things that you should find, okay? All right, let's see. So when you have those 5 numbers, they will make the end of the whisker, end of the box, the middle of the box, they will create a box and whisker plot. So let's talk about how to make this box and whisker plot by hand. So first you have to come up with this 5-number summary, minimum, Q1, Q2, Q3, and maximum. You will construct a horizontal scale that spans the range of the data. So from the smallest number to the biggest number. And you will plot these 5 important numbers, these 5-number summary above these horizontal scales. And the middle 3 dots will make the box for us. Okay, so from Q1 to Q3, we're going to draw a box. And we will extend those boxes with whiskers, like cat's whiskers, out to the minimum and maximum to finish the box and whisker plot. It sounds confusing if I'm just talking about it, but I can actually create one. Lastly, we draw the whiskers from the box to the minimum and maximum entries, and it will look like this. Take a look at this for me. I want you to look at how they plotted 5 important numbers, the 5-number summary. Minimum all the way on the left, maximum all the way on the right. Q1 is end of the box, on the left end of the box, and Q3 is the right end of the box, and median or Q2 is the middle of the box. So you have a box that's made up with the quartiles and the long whisker extending out to the minimum and to the maximum to the right side. That is how you make a box and whisker plot. I know in Algebra 1, at least I taught how to make these box and whisker plots by hand, but we're going to use StatCrunch to create those, okay? So it says, draw a box and whisker plot that represent the data set in the first example. So how about we do that again? Let me go in. I'm going to delete these because, and I'm going to go ahead and create a solution that looks like this. Oh no, this is the gallon of fuel wasted per year. This is the one example that we did in class together. So this one right here. All right, I'm going to pause the video so that I can type these numbers and I will restart the recording, okay? Yes, and they were fuels wasted, right? So I typed those data in there. I'll just call this wasted fuels. And we are trying to create a box and whisker plot. So you will go to graph, you will go to box plot, click, and then tell them that you want to create a box plot using waste fuel or wasted fuel. And you can do different things. You can use fences to identify outliers. I want to do that. Like for example, like I want to know if 11 is too small or 35 is too big to be considered outlier. So I'll go ahead and use fences to identify outliers, and I want them to draw this horizontally. I like it horizontally better. And then I can just go ahead and make a title, a wasted fuel, and compute it. And this is it. This is it. I can make this a little bit longer, and I'll take a screenshot of this. Okay. I can make this a little bit smaller. That's better. And do you guys see a dot on the left? Let me go ahead and click on this. See the dot? Wasted fuel of 11 gallons is an outlier because they marked it with the dot. So it's below the lower fence. That one is just too small. So that's an outlier right there. So let me go ahead and put that box plot right here and see if this is smaller to what they have. Theirs probably didn't mark the outlier. Let me make this a bit smaller. All right, compare these two box plots for me. They look about the same, don't they? Uh-oh. But what I did was something a little advanced. What we did on StatCrunch is that we told StatCrunch to mark the outlier with the dot. And that's how they didn't extend the whisker all the way out to 11. Okay, so this is how you can identify an outlier, by telling the box plot to use the fences to identify them. Okay, but they look the same. And what we can say is about the box represent about half of the data, which are in between 23 and 30. Okay, so the IQR is 30 minus 23. That's where the middle 50% are. And in my table, in my chart right here, which I will go ahead and make it, bring it to the next page, okay? I'll just copy this to the next page. In my chart right there, they did not really, as you can see, didn't mark it, right? I can't really see if this is 23. But if I go back to my StatCrunch and maybe put my mouse over on just a part of the graph, it will give me a little yellow box with all the informations listed. So maybe I will put that on this slide so that you guys can have that. So it marks everything. You didn't have to create a 5-number summary. It even gives you the Q1 is 23, median is 25, Q3 is 30. Whoopsie, look at that, guys. I think we found a way to check our lower fence and upper fence. They use the word lower limit, but anything smaller than 20 must be an outlier, and anything bigger than 35 must be an outlier. That is cool. Let me check real quick if that math is right. I may do it later, but that's a good way to check without actually doing the 1.5 IQR method if any value is an outlier. Okay, alrighty, let's go on. What's this? Oh, so they're talking about this box and whisker on this slide. The left whisker represent about 1/4 of the data. Okay, so this whisker that's going from 11 to 23, that is about 25% of the data. That's one section. This is 25%. This box from 23 to 25 is another 25%. 25 to 30 is another 25%. And lastly, 30 to 35, they have another 25%. So I guess they're making some, they're trying to talk about these here. So about 25% of the data entries are less than 23. Oh, we can see that because there's one whisker there. The right whisker represent about 1/4 of the data. So right there is another 25%. So this indicates that the data set has a possible outlier to the left. And we found it in our little outlier, right? By asking it to use the limits or the fences. Okay, so that's enough of box and whisker. I've been going for about 17-18 minutes, so I think I'm going to go ahead and stop this video so that I can get it processed, and I'll come back and talk about the ogive, okay?